Okay, our page 4 of 6.5, again, a little reminder of the things we've been doing. When you divide a polynomial more than one term, that's not a monomial, so more than one term by one term. You divide each term of the polynomial by the monomial, which is very fancy language, fancy lingo for what we did on the earlier page. You split it into individual fractions and divide each one individually. So that's on page 380. Also reminds you that to check a quotient in division problem, you multiply the divisor and the quotient. In other words, you can redistribute. We didn't really work out any of the checking on the papers here in the notes. If you want to see how that's done, you are more than welcome, especially if you aren't quite getting consistent answers, then we should probably talk about how you can check yourself. So definitely bring that up in class and we'll show you how to do that. Okay. So you're getting along through the assignment and then you hit the practice plus section, which is really 2 problems in one, looking at multiple steps here in these problems, but nothing new, just combining what we know into one problem. The instructions say to simplify each expression, and simplifying for our purposes, and this is a carryover from Math 60, is we want to remove the parentheses and combine like terms. So what if you were to see something like this, and this is number 80 from page 383. 6x cubed times the quantity 3x minus 1 plus 5x squared times the quantity 6x minus 3. Okay, so my question for you before we tackle this is maybe start by telling someone how you would start. Either tell yourself, or if you're watching this with friends or a buddy or a study partner, tell me how you would start this problem. What's your instinct? I'll give you a moment to do that. I'm guessing that some of you had the instinct that when you saw parentheses here, you had the thought, oh, I think I should distribute on the top. That is a great first instinct. In the sense that you could multiply the 6x cubed, okay? On the other hand, you could also see, well, we've got an entire term here, an entire term here. You could go ahead and start with some dividing, but it may turn out that you have to do that more than once. So I really like the instinct of distributing on the top and see what happens. Because then after that, what you might have told somebody is that you would then add like terms. After that, finally, you can do what we've been practicing in this section. You would split the terms into individual fractions and divide them. Okay, so that's just a way of how you could start that problem. Quickly over here on the side, what it might look like is 6x cubed times 3x would give you 18x to the 4th. Minus 1 would be a minus 6x cubed. Then you'd have plus 5x squared times xx would be 30x cubed. I'll run out of room here. 5x squared minus times a minus 3 would be a minus 15x squared. Sorry, let's rewrite that top there. It would be combining like terms 18x to the 4th. Then we have the negative 6x cubed and the plus 30. That would be a plus 24x cubed. And then you had the minus 15x squared, which I totally squished on the side here, but that came from that last distribution. Then that whole thing would be over 3x squared. From there, you could split this out into 1 fraction, 2 fractions, 3 fractions, simplify each of those. So that's kind of where that is headed.